Hello everyone, welcome back to lecture series on data structure. In this session we will be looking into how to remove a node from a singly linked list. Now let us consider we have this linked list comprising of 5 nodes n1, n2, n3, n4 and n5. After n5 we have no other node, so the next node of n5 is null, and as usual the first node is always identified by the head pointer. Now whenever you're going to perform an operation to remove a node, the very first thing that we'll check is whether the linked list exists or not, and that we can find out by checking upon the value of head node. That means we'll check upon if head is equal to null. That means if head is null, list do not exist, list is empty, so in that case we cannot remove any node. But if head exists, then depending on what user or which node user want to remove, we can broadly classify this topic under 3 categories. The very first category is that removing the first node. So we can say removing first or removing head. So let me say I say removing head. Second, removing the last node. Okay, remove last node. And finally we are going to remove any node that is between the head node and the last node. For example, over here the list which we have taken into consideration consisting of 5 nodes n1, n2, n3, n4 and n5. So if the condition head equal to null is false, that means we are going to have some sort of list something like this. Then for the first thing, removing head, so if we remove the head from this, you will get the list comprising of only 4 nodes. Those nodes are nothing but n2 to n3 to n4 to n5. After n5 we have nothing. Similarly, if you consider the same list from n1 to n5 and removing the last node, then in that case we will be getting the list such as n1 to n2 to n3 to n4. After n4 nothing, because last node has been removed. So for the third condition is removing the node that will be between the first node and the last node. That means you are going to remove anything between n1 and n5. So let us say I give this in a particular block, and from this block you are going to remove either n2 or n3 or n4. Either one of the node you are going to remove. So here we are saying remove in between the first, that is the head node, and the last node, whatever the node may be. Okay, so this is these are the 3 methods which we will be implementing in this session. Okay, before we start the coding part, let us go through this once again. In this topic, that is removing the node from the singly linked list, we are going to consider 3 types of removal. That is, first condition is removing the head node. Second, either we may remove the last node. And the third condition, or the third objective over here, what we can say is removing any node between first and last, that is the head node and the last node. And before we remove or take into operation of removing any node, first thing what we'll check is whether, or what we should check is whether the list exists or not, that is whether head is null or not. Okay, so now let us start with the first topic, that is removing the head node. Okay, the first topic is removing head removing head or removing first node. Okay, now definitely the first thing what we'll check is whether list exists or not. Okay, if list exists, then we'll operate this, or else we'll be displaying the information that list do not exist. Now here let us say we are having 2 conditions. The very first is there is only 1 node in the list. Okay, and if we are going with this condition, that is we'll check over here if head next is equal to null. This condition will definitely come in the case there is only a single node in the list. If this is the case, then what we'll do, we will remove head. In C and C++, we have an inbuilt function called delete. This function is used to erase or remove the memory blocks those are being used by arrays and the pointers. Okay, whatever the nodes or whatever the list we create by using nodes, and those structured nodes. Okay, and those are nothing but the pointers. So what we'll do over here, in the case there is only one element in the list identified as the next pointer of head is null, then in that case we'll simply say delete head. So that pointer will get destroyed, and so the list will be empty. But what is the second case? That means it will come in else part. Else part something like that. We may have something after 10, we may have 20, and thereafter null, or we may have 10 to 20 and 20 to so on, so that we may have two or more elements, and last element, let's say I write n0. I do not know what's the value of n0, and let it be null. Okay, then either of the case, okay, the first element is identified by the head pointer. Okay, now what we want to remove this head. So what we'll do, we'll take one dummy pointer. Let's that dummy pointer be m. Okay, and that m will be of the same type as that of head. So we'll say m equal to head next. M equal to head next. The moment you say m equal to head next, that means where the next pointer of head is pointing, or where the next pointer of 10 is pointing, it is pointing to 20. So from this list, if I'm saying taking the first one, 10 to 20, after 20 there is null. Here head is at 10 and m is at 20. Similarly, if I go with the second one, 10 to 20, after 20 there are n number of nodes, and last node is n0, and here we are saying the next pointer is null. So even in this case, head is pointing at 10 and 20, or at 20 what we are having, the node m. Now we want to remove the head node. So here we'll straightway say head equal to, or not head equal to, we'll simply say delete head. Delete head. So the moment we give this operation to delete head, what will happen? This pointer or the first node will be erased. Okay, if the first node is getting erased, then the list will comprise of only 20. If I consider the left part, it will have only only one node having value 20, and next pointer is null, and this is identified by m. And in the second case, we are going to have 20 pointing to some other node, and the last node will be node no, and then next pointer of no is null. And again here the first element, that is 20, is identified by m. But in the list, we always say first node should be is identified as the head node. So after deleting head, what we'll say, we'll simply say head is equal to m. That means we'll reassign head. So with this, for the first the list which is over here, where we are having only element 20 and the next one is null. Now this 20 is identified by two nodes, one the head node or the head pointer, and second, that is m. Similarly, it will happen to the other list where we are having n number of nodes. First node is identified as 20 and by node m. Now this will also be identified by node head. Okay, simple over here. So here topic what we will be covering in this session is only if how to remove the first node, or what will happen if we remove the first node. So before removing any node, we'll first check whether list exists or not by checking upon the head pointer. If head is null, list do not exist. Okay, else. Now the first part, what if there is only one element in the list? Okay, one element, that means let us say over here we have added an element called first only one node in which we have stored the value 10 and the next pointer is null. So if this is the only list and we are removing this element, we are removing the head, then what will happen? The list will become empty. So we here will check. How to check upon that? We'll check by using the next pointer. If the next pointer of head is null, that means there is only one element, then just delete the head. So automatically you do not have a list. All right. Whereas the second case, that means the next pointer of head is not null, then in that case we can consider that the list will have at least two nodes. First the head node and second onwards whatever the nodes may be. It may be, we can again consider in the two ways. Either it may have only two nodes, head and the next node, or you may have n number of nodes, head, second node, third node, and so on. So what we'll do in that case, we'll create another dummy node, okay, or the pointer of the same type as that of the head, and we will assign that dummy pointer or dummy node m to the next location of the head or the next node of the head. Now head is at first location, so the next location is identified by the pointer next, or the second position is identified by the next pointer of head. So we'll simply say m equal to head next. So in this list, the way the first element is 10 and second element is 20, the first element 10 is identified by head, and now 20 is getting identified by m. Now you know where the list will start in the case if you remove the head node. Alright, so what you do, now you first remove the head by using delete method. So what will happen, that whatever the memory space that has been utilized, that will be freezed off, or that pointer, the head pointer, will be erased off, and then we will get the list with m, that means the only one node, that is 20, or in the case we are having multiple nodes, first we will start with 20, and in both this list first element is identified by m. But when we say we have a list, the first node should be always identified by the head node or identified as head node. So what we'll do, we'll reinitialize the head, reassign the head, then we'll say head is equal to m. As m is pointing to the first node in the list, what will happen, the moment we say head equal to m, now head will be pointing to the first node. Okay, so this is the theoretical aspect of how to remove the first node. Okay, now we'll just look into this. We'll have the code of this right away. Okay, so this is the program which we have been doing. Okay, in that we have first consider adding of nodes, first three cases: add at first, add at last, and add at last, or add at a location. Now what we'll do, this display method is there, accepted. Now after that we will change the condition. Over here we said at 4 we are displaying and 5 we are quitting. Now at 5 what we'll do, we'll give an option to remove first node. Alright, and then at 6 condition we should be able to quit. Okay, so this I change the case and case will become 6, and here I say case 4, or not case 4, case 5. Case 5 is remove first node. So I write one function remove first, either you can say first or head, either of one. So let us say remove first. Okay, let this be function, and let me have one break statement over here. Okay, so let us implement this function. Function is remove first. What I do, just our main method, I will implement this. Okay, it's the same code. If you have gone through previous sessions, it's the same code. We are just amending that code. All right, so void function name is remove first. Okay, so as stated over here, what even if you are going to remove the element, what we need to check first, we need to check whether head exists or not. That means if head equal to null, we'll simply say nothing to remove, list is empty. Alright, so that we'll put in the first code. So whenever we are calling upon this function to remove the head, we'll check upon if head equal to null. If head equal to null, let me increase the font. Okay, I think this is sufficient. If head equal to null, then we'll give one statement backslash n, list is empty, nothing to remove. All right, so this is the case. This case will happen in the case we are trying to remove the head and the element do not exist. Okay, now we'll come into the else part. Now in else, again there are two conditions. What if there's only one node? That means we are looking into this condition A and B. First condition is there is only head node. And how to check if the list consists of only head node? We'll check upon if the next pointer of head is null. Okay, else what we are having more than one nodes in the list. So the first part will check if there is only a single node. Okay, so that is if next element of head is, or next pointer of head is null, head next equal to null. Okay, then what we'll do, we'll tell the user what element we are removing, and then we'll just remove that element. Okay, if you simply write like this, delete head, okay, the head will be removed, but you are not telling a user which element you are removing from the list. So what we'll do, we'll make it a little bit user friendly over here. We'll display a message cout backslash n element removed. What element we have removed? That is the value of x. So we can say head next, and then you remove the head. Element removed. What's that element? That is the x. Okay, the first element, whatever it may be. And let us say we give some tab over here, so it will come a little bit ahead and it will be visible. All right, now this is the thing when you are removing or when you are having only one element in the list. Else, now you are having more than one element. So what you'll do, you'll create one dummy node, struct node, let us say m, because head and m must be of the same type, or all nodes are of the same type. All nodes are the pointers of type struct node. Now here we'll assign the value, or we'll assign the position m to the next location of the head, that is the second position in the list. Now second position in the list is identified by the next pointer of head, so m equal to head next. Okay, so now what's happening over here, if you let me rearrange this if possible, if I can take both on the screen. Okay, that's better. Over here we are at this part, 10 to 20, after 20 null, or 10 to 20 and so on. All right, so what we have done, we have created one dummy node m, and we are saying m to point to the next location. So we are having now m pointing to 20. Let me like now m is pointing to 20. After this, what we'll do, we'll remove head, that is destroy head. So delete head. So after this statement gets executed, what will you will be left with the list starting from 20. Either you may have only 20 or you may have more than 20. All right, that means either single node or more than one nodes. All right, and after this, what we'll do, we will reassign head to m, because right now the list starts with node m, but it should start with head. So what we'll do over here, we'll simply write head equal to m. Okay, now let us cross check and let's execute this first. Okay, where is the, okay, here it goes. So let's rebuild and execute the project. Rebuild the project and execute. Either you can do it this way, or what you can do is you can just follow this workspace or workspace pane and click on this run symbol. All right, so your project will be running over here. So we get over here. So let us say we are trying to remove the first node, we are directly going for 5. So definitely the list is empty, nothing to remove. This is coming, that's very much sure, because right now the head pointer is null. Now let us add few nodes. Okay, let us say we are adding first at first. So we are going for the first option. So let us say at first we are adding 10. Okay, so we got few elements in the list. Again there is a choice. Let us say we are again adding the element or node at first. Okay, so I go for the first choice and I add 20. So if I try to check into my list consists of 20 followed by 10 and not 10 followed by 20, because we have added the nodes at first. Let's cross check. We'll go for the fourth option, that is display. Here you get 20 followed by 10. Okay, so now what we'll do, we'll add the element at last. We'll go for the second option. Okay, for second option what we'll do here, we'll go for 2, and now let us say I'm adding 30. Okay, so I'm adding 30 at last. So in that case my list will now start with 20, then it will go like this: 20 to 10, 10 to 30. Let's cross check. We'll again go with display, fourth option. Yes, here we get, actually we should have given one backslash, we should have given one tab by using backslash t, so that what would happen, this 20, 10 and 30, which is just coming immediately below this fourth option, no, or this written sixth option, that is quit. We should have given tab so that it would have started somewhere ahead. Okay, no issues. We'll do it in the next immediately after this. Okay, now we have the list. Now we will go for the main objective of this session, that is removing the first node. Okay, now the first node is 20. So let me say I go for the fifth choice, that is to remove the first node. Okay, now it should be like this. Remove. Okay, it didn't go, something we missed over here. Let's check. Remove first, remove first. Okay, let me display the list once again. If we're going for 4, yeah, it removed the first node, got removed. All right, but okay, we didn't display anything over here, no, that is the case. If you're going for this, we didn't display the value of x, so it just went that it just removed the node and it didn't display. Okay, the program is proper, it worked properly. Let us say we remove one more element. Okay, so removing first, so now 10 will be removed. Now if we remove, let us say now we are calling for the display method. Okay, so now in display method you are having only 30. So in the previous case you are having 30 and 10. We should have given this statement also in the way we have said, no, if there is only one element, then we are displaying. But what about if you are having multiple elements, then this statement should have been over here before we remove or delete the head. We'll just try for this. Let's go for the fifth, remove the first node. Here you get element removed 30, because that is only the node of what we are having, no? So what we'll do, we'll let's see, we'll modify this quickly. Okay, so what we'll do here, let me just copy paste. Before we remove the head, we should know what element we are removing, and also while displaying the list, no, while we are calling upon this function, let us say we give some like this \n list elements I will give here \t. With that it will be a little bit ahead, one element one and less, and after this, no, okay, let me have 2 lines, let me leave 2 lines. Now let's re-execute this. It was working properly, no issues. Only thing was that it wasn't displaying which element it is removing. Okay, so we are re-executing this. So option first, so we are going for 10, adding element at first. Again we are going for the first option, that is adding element at first, so we get the list 20 followed by 10. Now we are going for the second choice, that is adding at last, and here we provide the element as 30. So now we are having the list 20 to 10, 10 to 30. We can cross check, we will give the fourth option. Now option is to display the list, so fourth option, now here you get it. Now this is proper, this is what I was saying, it should display a little bit ahead. So list elements are 20, 10 and 30. Okay, now what we'll do, we'll go for the fifth option, that is to remove the element. Okay, so fifth, not remove the element, remove the first node or nothing but the head node. So if we give fifth option, and here you get remove element removed 20. Again enter the choice and something like this. Okay, after this there should have been \n, not an issue. So it worked, and now if you display the list, you are getting 10 and 30. Okay, we can do something like this also, that after we remove the head node, what is the what are the, what you say, remaining elements. Okay, we'll just rectify this once again. So after we remove the head, okay, that means after we remove any after we remove the head element, so either there is only one element, there was only one element or multiple elements, what we'll do, we'll call upon this method here only, from here only, so that we should not go for choice 4 again. Okay, so we'll be getting this list and displaying the list. Anything else? Okay, and every time it was coming on the same line, so what we'll do was switch for this while loop. So whenever it's coming for the next choice, let's have some space. So this was related to switch, and after switch, let me say I give here \n. Okay, you can align it as per your convenience. Okay, so now let us check with the list. Okay, so I'm going for the first option, add at first, so I'm adding element 10. Then again I'm going for the first option, that add at first, now add 20. Now I go with the second option, that is to add the element at last, so now I'm adding 30. So my list now consists of 20 to 10, 10 to 30, that should be the list. So I'm going for the fourth option. Here you get list elements 20 to 10, 10 to 30. Okay, now after this, let us say we are removing the first node, so that is the option number 5. So here you get, yes, it worked, element removed 20. Now the list element consists of 10 and 30. Again I go for the fifth option. Now element removed is 10, so you are having the previous list consisting of 10 and 30. Now element which you are removed is 10, and now remaining elements are only one, that is 30. Now again I remove the fifth node. Okay, so fifth node, that means I go for the fifth option, that is remove the first node, and the list we are having only one node, that is 30. So it will display that element removed 30,